One of the things we need to figure out how to do is to write total ionic and net ionic equations. So a couple things we need to know about that. Definitions are first. Total ionic equation tells us about the soluble ionic compounds in solution, and they exist in solution as ions. So we make that known by writing them as ions. Compounds that are solids, so don't dissolve in water, gases, and polar compounds are going to be written as compounds because they are not going to ionize in water. A total ionic equation includes all the ions present in the solution. A net ionic equation is different. Net ionic equations include only those species that change from the reactant side to the product side. So it's usually going to include far fewer things than in a total ionic equation. The ions that don't change from reactant side to product side are called spectator ions, and we don't include them in a net ionic equation. If we're going to write a total ionic or a net ionic equation, these steps are useful to follow until you get really good at it. Let's say I start with a solution of barium chloride and a solution of potassium sulfate. Both of those are ionic salts, so we can write them as a total ionic equation. First step is to write a balanced equation. I'm given reactants, so I need to write out their formulas first. So I have barium chloride plus potassium sulfate. Then I need to write the products. I should be able to predict their products are going to be barium sulfate and potassium chloride. I want to make sure it's balanced. Second step, I'm going to write a total ionic equation. So if I have a solution that is an ionic compound, I'm going to write that compound as ions in solution. So barium chloride is soluble, it's an ionic salt, so I'm going to write barium ions plus chloride ions, and I have two chloride ions, so I write them like that. I have two potassium ions, and I have a sulfate ion. So there are my reactants, and now I need to look at the products. My products are barium sulfate and potassium chloride. From our solubility tables, which we'll be getting to, we find that barium sulfate is an insoluble salt. Since it doesn't dissolve, we're going to write it as a compound, so we write it as barium sulfate. Potassium chloride is soluble, so we'll write it again as two potassium ions and two chloride ions. So there's our total ionic equation. The third thing we need to do now is write the net ionic equation. From our total ionic equation, the easiest thing to do is to find the spectator ions and cross them off. A spectator ion, again, is something that doesn't change from the reactant side to the product side. So if I take a look at this total ionic equation, the chloride ions present on the reactant side are also present on the product side, so I can cancel them out. Potassium ions are present on the reactant side and also on the product side, so those get canceled. Whatever does not get canceled then becomes the net ionic equation. So I have barium ions plus sulfate ions, so that's my reactant, and I have a product of insoluble barium sulfate. So there is my net ionic equation. What changes? Ions forming an insoluble compound. Okay, let's take a look at a couple others. Here we have carbon dioxide bubbled into water. First step again, we're going to write the balanced equation. So, carbon dioxide plus water. Okay, we went through this in class the other day as a predict the products. I'm going to get carbonic acid. Now I want to write the total ionic equation. Carbon dioxide's a gas. Furthermore, it's a covalent compound, so I can't break it into ions, so it's just going to be CO2. Water, not an ionic compound, polar covalent compound, can't break it into ions, stays as H2O. Carbonic acid, on the other hand, is an acid. Acids are electrolytes, they ionize. Turns out carbonic acid is going to ionize and form one hydrogen ion and a bicarbonate ion. How would I know that? Well, lots of experience. The other way that you could conceivably write it, if you weren't aware that it breaks apart this way, is to say that I have two hydrogen ions and I have a carbonate ion. Either is acceptable. If you're writing net ionic equations or total ionic equations for the AP test, either of those would be accepted. So now my next step is I want to write my net ionic equation, so I'm going to cancel out those things which do not change from the reactant side to the product side. If I look, on the reactant side I have molecules and no ions. If I look on the right, I have ions. And so everything changes. So my net ionic equation is equal to my total ionic equation. And sometimes that happens. And that's okay. My next reaction, I'm going to look at nitric acid reacting with a solution of lithium hydroxide. So we're going to start out by writing our formula, balanced equation. So here's nitric acid plus lithium hydroxide. Okay, this is a neutralization reaction, so I'm going to get lithium nitrate and water. Next step, write out the total ionic equation. So nitric acid is an ionic compound, so I get hydrogen ions, nitrate ions. Lithium hydroxide bases are ionic compounds, so I have lithium ions, hydroxide ions. Lithium nitrate is a soluble compound. One of the things we will learn is all nitrate compounds are soluble. And then here's water. Water's polar covalent. Can't break it into ions, so I write it as water. From my total ionic equation, I'm going to cross out those things that don't change. I have nitrate ions on the left and on the right, so they get canceled. I have lithium ions on the left and on the right. They get canceled. What's left? Hydrogen and hydroxide ions on the left, so I have hydrogen plus hydroxide, and I end up with water on the right. And so there is my net ionic equation, and it's just the formation of water from ions.